Hello everyone. So last time we saw TCP. So today we will see the UDP, that is user datagram protocol. And just like TCP IP, it also works in transportation layer or of OSI model. So I hope you have already seen the video for OSI model and TCP protocol. So now let's quickly jump into what is UDP, what is user datagram protocol. User datagram protocol or UDP is a combination communication protocol that is primarily used to establish low latency loss tolerating connection between applications on the internet. So let's understand. First thing is low latency and loss tolerating. From this statement, we already understood the part that UDP have low latency. That means it sends the data in real time. And loss tolerating connection, it means the connection can tolerate the loss. And we can say connection tolerate the fact that there might be some data missing. Okay. UDP speeds up transmission by enabling the transfer of data before an agreement is provided by receiving party. So we know in TCP protocol what used to happen. We sender or I would say client used to request the server, and then there some connection used to occur. After that data transmission used to happen, right? So there was some agreement between sender and receiver, and in because of this agreement and because of multiple acknowledgements, so as we know already that in TCP protocol, after sending every package, once every package is received, we get some acknowledgement from receiver side, right? But in UDP, this mechanism is not present. And due to this fact, the speed of transmission increases because now we don't have to do agreements, we don't have to do handshakings, we don't have to provide acknowledgement every time. Due to this, the transmission speed increases. As a result, UDP is beneficial in time-sensitive communications, including voice over IP, domain name systems lookup, and video and audio feedback. To understand it more properly, let's assume a scenario. Assume you and your friend done a WhatsApp call. Your friend said, "Hi, how are you?" So what you expect? You expect that you get this message immediately, right? If this message come with some significant delay, then communication don't occur properly. Assume message come after 3 seconds. What you will do? You will try to talk something else in between this time. And again, due to some delay, communication won't occur properly. Here, UDP comes into the picture. For an example, if your friend said, "Hello, how are you?" And though You don't get the voice for how, but you listen, hello, are you? So you can understand. He want to say, how are you? In this kind of scenario where the speed is most critical or real time data transmission is more critical than the guarantee of data communication. In this kind of scenarios, we use UDP protocol. UDP is an alternative to TCP, that is Transmission Control Protocol. Both UDP and TCP runs on top of IP and are sometimes referred as UDP/IP or TCP/IP. However, there are important differences between these two. For example, UDP enables process-to-process communication, while TCP supports host-to-host communication. I previously explained what is host-to-host communication. Now let's focus on process-to-process communication. So here, talking with your friend on WhatsApp call. So here, calling is a process. Okay. So instead of having the host to host oriented communication, UDP enables process to process. Instead of ensuring that host is connected and host is providing the acknowledgement and there is a session between two hosts, here UDP focuses on the process, that the process of calling and communications occur properly. TCP sends individual packets and is considered a reliable transport medium. On the other hand, UDP sends messages called datagram and is considered a best effort made of communication. What does it mean? It means UDP tries best to send the datagram or message packets to receiver, but it is an best effort. It is not guarantee. This means UDP doesn't provide any guarantees that data will be delivered or offer special features to transmit lost or corrupted message. UDP provides two services not provided by the IP layer. It provides port numbers to help distinguish different user requests. It also provides an optional checksum capability to verify that data arrived intact. UDP protocol features. So UDP has attributes that makes it beneficial for wide application that can tolerate lost data. Below are example. It allows packets to be dropped and received in different order that they were transmitted, making it suitable for real-time applications where latency might be a concern. It used for transaction-based protocols such as DNS or network time protocol. So DNS and NTP. This is also very important protocol. In future, we will discuss deep into it. So DNS have some lookup table. For an example, you type www.google.com. But server of google.com is an IP address. So how your browser know where to go? So here DNS service comes into picture. And we want it fast, right? We want it fast. It is not like we type google.com, then after some time IP is coming, then the request and response process starts. It can be used where large number of clients are connected and where real-time error correction isn't necessary, such as gaming. voice or video conferencing, and streaming media. UDP header composition. So let's see what all the things in UDP header we do have. UDP uses headers when packing message data to transfer over network connection. UDP headers contain set of parameters called fields defined by technical specification of protocol. The user datagram protocol headers has 4 fields, each of which is 2 bytes. They follow following: source port, which is the number of the sender; destination port, the port to which datagram is addressed; length, the length in a bytes of UDP header; and any encapsulated data; and checksum, which is used in error checking. Its use is required in IPv6 and optional in IPv4. So no need to worry about this point. We do have one chapter for IPv6 versus IPv4. There we will understand the IP protocols in much detail. What is IPv4, what is IPv6, where this two differs, and so on. So as you can see, we have UDP header like this. Sorry for the clarity. You can check the clear picture in our Skillanything website. How UDP works. UDP uses IP to get datagram from one computer to another. UDP works by gathering data in UDP packet and adding its own header information to packet. This data consisting of source and destination port on which communicate the packet length and checksum. After UDP packet are encapsulated in IP packet, they are sent off to their destination. Unlike TCP, UDP doesn't guarantee the packets will get to right destinations. This means UDP doesn't connect to the receiving computer directly, which TCP does. Rather, it sends the data out and relies on devices in between to sending and receiving computers to correctly get the data where it's supposed to go. Most applications wait for any replies they expect to receive as a result of packets sent using UDP. If an application doesn't receive a reply within a certain frame, the application sends the packet again or it stops trying. UDP uses simple transmission model that doesn't include handshaking dialogues to provide reliability, ordering of data integrity. Consequently, UDP service is unreliable. Packets may arrive out of order, appear to have duplicates, or disappear without warning. Although this transmission method doesn't guarantee that the data being sent will reach its destination, it does have low overhead and is popular for services that doesn't absolutely how to work the first time. So let's understand it. I know you didn't got it perfectly. So assume there is some sender and there is some receiver, or again client and server. So what receiver do? Receiver sends a UDP packet by asking some data. Okay, some data it asks. So what server or sender do? Server and sender make the packet by attaching the UDP header. And remember, UDP header is associated with the UDP. After that, IP addresses and all other network headers get attached and the body is also present. Then it sends the data. So does it sends the data directly to the receiver? Answer is not. Data packets do have the address of receiver. Now it is about the intermediate network devices that it must or it should send transfer this data to the receiver. So it might be possible some device is bad device. In IoT terminology, we call it bad node or miscellaneous node. In both this scenario, data don't get transmitted to receiver. So if everything went well, okay, great. But here receiver is also no. There is a possibility that data might loss in network. Unlike TCP, in TCP there is no possibility that data might loss, but in UDP there is a possibility. To address this concern, what receiver and do, receiver define some time frame that within this time if message come well and good, else I will stop listening and again send the request for the data. And there is some threshold value for retrying in receiver side also. If that threshold is reached, receiver or client stop requesting only. So I hope now it is much more clearer to you. Application of UDP. So first application is lossless data transmission. What does it mean? In many systems, we want that when some losses occur, we want to resend that packet to receiver or client side. How can we do that? Here UDP protocol shines because I maybe I don't want to again re-establish the connections for a particular packets. So here I can use the UDP protocol, gaming and voice and video, as I explained before, services that doesn't need fixed packet transmission, multicasting and routing protocols, fast applications. So I will appreciate if you read all this theory and much more is provided in our Skillanything website. You can go through it so you can get deeper understanding. Now let's quickly see the comparison chart. TCP versus UDP. TCP keep track of lost packets. Make sure that lost packets are resent. UDP doesn't keep track of lost packets. Add sequence number to packets and orders any packets that arrive in wrong order. Doesn't care about packet arrival order. Slower because all added additional functionalities. Faster because it lacks extra features. Requires more computer resource because the OS need to keep track of ongoing communication session and manage them on a much deeper level. Requires less computer resource. Example of TCP protocols, that is HTTP, HTTPS, FTP, SMTP, so on. Here UDP is DNS, IP telephony, DHCP, and many computer games. So I hope you got a clear idea what is UDP, how it works, how it differs from TCP. In case you have any doubts, any questions, you can drop it down in comment section. And even better, I would say, go to Skillanything website, go to lesson, give it a good read, and still you have some doubt, there are feedback and comment section for each lesson. You can provide your feedback there and our TAs will definitely reach out to you. So that's it for this video. See you in the next video. Till then, bye.